Hello, this is the fourth video of the Critical Path Analysis Series 2 on cascade charts and scheduling, and we'll look further at resourcing and scheduling. If we are told that each activity takes one person and that all activities start at their earliest start times, we may be asked how many people are needed for the project. To start planning the resources or answer this question, we can look down the columns for each time unit, on the assumption that all people can do all the tasks, which may not, of course, prove to be the case. But we will assume it is, unless told otherwise in the question. In the first time units, say 1 through to 7, we can see that we only need 2 people. Thereafter, we need 3, and at this stage we would need 4, and then back down to 3 and 2, simply by looking at the number of activities being undertaken at a certain time. We've already seen some examples where we have considered what resources are required for a project, generally people. One way to help with this is to draw a resource histogram, and this can be useful to help determine efficient use of resources and to then develop a schedule for a project. Sometimes the number of workers required for an activity is given in brackets in the cascade chart. If these numbers are not given, you may assume that only one worker is required. We also assume that we always use the earliest start time unless otherwise stated in the question. Always build the bars up from the bottom, and note that there should be no holes or overhangs. Thus you can see that from days 1 through to 8, we will need 2 workers for A and B activities. Then through until 11, we will need 3 activities for C, B and D. And then through to 16, we would need 4 workers for activities C, D, F and G. And then back down to 3 activities. This would give us the resource histogram shown here. You'll note that when we said no holes or overhangs, it meant that we did not, for example, when we're looking at H and I, put a block for H sort of up in the air here and then have a hole down here. Sometimes you may wish to label each block of a resource histogram with the letter of the activity being undertaken. These resource histograms can be used for other resources as well as workers. A schedule then lets the work required from each worker be calculated. Now you will be expected to use cascade charts, resource histograms and also common sense to construct the schedules when restrictions apply. The scheduling assumptions are that once an activity is started, it must be completed by the worker, that once a worker has completed an activity, he or she becomes immediately available to start another activity, so no breaks need to be taken into consideration, that you should always use the first available worker rather than sharing the work out, and if there is a choice of tasks for the worker, assign the one with the lowest value for its latest finish time, as shown on the activity network or cascade chart. So from the resource histogram, we could see that we would need 4 workers for the project, because at times on the project we needed 4 workers. So let's think about what tasks we would give each of those workers based on the assumptions in the previous slide. So I'm going to give worker 1 all the critical activities. So A, C, E, H and J, because I'm assuming no breaks, and so that person will just work straight along from 0 to the completion time. So then worker 2 would start on activity B. They couldn't do D because they'd still be working on B, but they could then do F. They can't do G because they're working on F, but they could then do I. Worker 3 would then do D. And the way it's scheduled at the moment, then worker 4 would pick up the task G. At this point, if you were the manager and thinking about paying the workers for the project, you might be wondering whether you could possibly manage with fewer workers and save some money. Whilst worker 1 is at full capacity, the same cannot be said for workers 3 and 4. We can see that G has considerable float, and if we were to reschedule G to start later after D is completed, then we wouldn't need that fourth worker. So by rescheduling G, we can see that we would manage with only 3 workers. So the initial solution, where all the activities started at the earliest start time, was not the most efficient, and you need to be able to interpret the resource histograms and use the floats where appropriate to reschedule the start times. The resource histogram could then be redrawn accordingly, and this is sometimes called flattening it. And you can see here that those 4 blocks for G have been moved along from where they were, and therefore that we can see that 3 workers is sufficient for the whole project. This is the last video of the CPA 2 series.